We will now move to the next section 4.5, and this section comprises of the first stage wavelets. We will construct what is the first stage wavelets on Z. Zn we have earlier constructed this first stage wavelet basis up to pth stage wavelet basis. The same technique analogous to what we have done there, we will use here also. And first for this, here we also have theorems and lemmas that is very much analogous to that we have proved in the finite case. This is the one similar item. The set suppose W Z belongs to L1 of Z and the set R2K. Even number translates of this W is orthonormal if and only if this modulus of W cap of theta. Cap means the Fourier transform that we have defined in the section 4. The back section 4.3, and this W cap of theta plus pi the whole square is equal to 2 for all theta belongs to 0 pi. The similar one of these this result can be seen in the finite case also. We have proved there, and we have this inner product between different cage, not different cages belongs to Z. We have this inner product is equal to 0 if and only if this identity follows for all Z and W, or for all theta belongs to 0 pi. And yes, for a first part basis, the result is the proof is similar with that of the discrete case that we have done. And for this take a W which is non-zero, you take, and we construct elements for k belongs to Z are 2kw. This set we construct R2kw, k belongs to Z, we construct, and we now prove this all these elements for distinct k, the elements are also distinct. That is, for each k we will get R2kw as another element, not with the same element that we have produced. That is R2kw if for two indices k and j, if the elements R2kw and R2jw are equal, then we can say that k is equal to j. 1 minute. Okay, uh, for this result we will prove the exercise 4.5.1 to 4.5.1 first result also, then we will prove second result. For this we have this note, and lemma 4.4.2 first part is suppose 1 minute. Suppose that W belongs to L2 of Z, and if there exists an index k such that RKW is equal to W for all n, that is RKW of n is equal to W of n, then we can prove that this W is equal to 0, that is W of n is equal to 0 for all n. For this we will in proving this, we can see that suppose by contradiction, we are taking contradiction that this for all n this is not true. For some n there is some m belongs to such that W of m not equal to 0. W of m not equal to 0 implies that W of m can be positive or negative. Suppose that W of m is equal to positive. If negative, you can prove the result for minus W. For minus W, then the minus W of m will be positive there. Okay, without the loss of generality, we can take this W of m is equal to positive number epsilon greater than 0 for n1 is equal to k plus m. What is k and m? K is that number such that RKW is equal to W for RKW of n is equal to W of n for all n. K is a fixed integer, and this m is where m is the one that we find for such that W of m not equal to 0. So we compute n1 as this fixed k plus fixed m, that is n1. Now we turn to RKW of n1, we compute. We know that RKW is equal to W, so RKW of n1 will be equal to W of n1, that is given. And what is RK definition on W? It is W of n1 minus k. This W of n, this comes here, n1, this comes here. What is n1 minus k? Here from this result, n1 minus k is equal to m. So w of m is equal to w of n1. So we have produced another index n1 such that it is equal to w of m. W of n1 is equal to w of m. So at uh, at the first stage, w of m was non-zero. Now we have produced a further term, w of this n1 is equal to w of k plus m is equal to not equal to 0. Then again we will produce n2 such that with the same calculations we will get, and this rkw of n2 is equal to w of n2 given, and our definition of rk is w of n2 minus k, w of n2. 1 minute. Okay. Okay, 1 minute. Okay, this n2 minus k, what is defined? N2 is defined like this. So n2 minus k will be k plus m. So this 2k can be written as k plus k, and k is taking left, and k plus 1 we will get w of n2. So w of n1, what is k plus m? K plus m we already derived as n1, taken as n1. So w of n1 will be equal to w of n2. So we have produced another index w of n2 such that it is not equal to 0. So proceeding likewise, we will get infinite number of indices n I such that n I is equal to ik plus m. 1 minute. Okay, ik plus m, I is equal to 1 to infinity such that its value at w's value at this index will be equal to epsilon, which is greater than 0 for all I belongs to z, plus this implies that summation n belongs to z mod w of n, the norm mod w of n the whole square, because a lot of positive terms are coming in this summation. So the same term is repeated infinite times. If in a series a term is repeated infinite times, then that series cannot be convergence. It diverges to infinity, because the positive is adding, and again it goes to a higher number when add up to infinity. So this will not be a finite value, but we have proved that you have taken that w belongs to L2 of z and also to L1 of z also. Suppose w belongs to L2 of z we have proved, and that we have taken w. No, this implies that w does not belong to L2 of z, which is a contradiction to our assumption. So what is our assumption is wrong. That is w is equal to 0 for all n. For it will not be non-zero for any such index m. So we have this w of n is equal to 0 for all n. So w will be the 0 element. So what we have proved is that if but w belongs to L2 of z and there exists k such that rkw is equal to w, then w will be equal to the 0 vector. So now we will move on to the next result that we needed. If there exists kj two indices belongs to z such that they are not unequal indices such that rkw is equal to rjw, then we will prove w is equal to 0. That is if the indices are distinct, the elements will be distinct. That is the case here. Now uh, 1 minute. This w is equal to w will be 0. If we take a non-zero, that what is the meaning of this statement? If we take a non-zero w, then there will not exist kj belongs to z such that k not equal to g and rkw is equal to rjw. It means that if w is a non-zero vector, then the indices k and j rkw will not be equal to rjw. All the elements, all the translates of w elements will be distinct. It is the essence of this result. And suppose there exists kj belongs to z and k not equal to j such that rkw is equal to rjw, k and j are fixed here. Now rkw of n will be rj of w of n. That is, we have taken for all n. What is the definition of rkw? W of n minus k will be equal to w of n minus j for all n and kj fixed. Now this n is taken as m plus j, because this j is k and j are fixed here. this j is fixed, m is running, so n will be running, and m is running and m belongs to an integer, and m ranges from minus infinity to infinity integer values. So now we calculate w of m plus j minus k will be equal to w of m plus j minus j, because for this n we have taken m plus j and applied here. What is the result? This m plus j minus j, what will be w of m for all m belongs to z. This is true for all m belongs to z. That is w of m minus, what is this, j minus k can be written as minus of k minus j, and is equal to w of m here for all m belongs to z. So what is this w of m minus k minus j? It is r k minus the w of m will be equal to w of m for all m belongs to z, and thereby we can write r k minus j w is equal to w. From where we have started, rkw of n is equal to rjw of n. We have entered in rk minus jw is equal to w. So if we take if there exists k and j distinct such that rkw is equal to rjw, then this identity, this equation can be now rewritten as rk minus jw is equal to w. In the That is, there exists an index that is k minus j. K and j are distinct, so this cannot be equal to 0. This will be another integer. So if suppose there exists an integer such that r k minus jw is equal to w, we have proved in first case one result, we have proved that is equal to 0. So in this case also we have proved this result, w is equal to 0. So what is the implication of this result? If we take different distinct indices, the elements, the translates, even number translates of distinct elements will be distinct. Distinct indices will be distinct. That is the core of this result. Now, now we will prove that if this quantity is periodic with pi, because w cap has period 2 pi. We have taken w and initially we have uh, this w cap and z cap etc. Initially we have defined for 0 pi, and we have extended it to full of r by taking the period. It is this 2 pi 2 pi period, that is w cap of theta plus 2 pi is equal to w cap of theta. So what we will write here, this expression, compute this expression, uh, is period, sorry, period is this expression is periodic with period p, and w cap has period 2 pi. So we will prove that this expression is periodic with the pi. What will we to compute? Now we take w cap of theta plus pi to prove the periodicity with pi, and whole square plus w cap of theta plus we will replace this theta by theta plus pi, uh, also this theta plus pi, again one pi is there, this bracket closed. What is this one modulus of w cap of theta plus pi the whole square plus w cap of theta plus pi. What is type? Pi plus pi 2 pi. So w cap is periodic with the 2 pi period. Then we can write that w cap of theta plus 2 pi is equal to w cap of theta. So we can write mod w cap of theta whole square. So this expression will be periodic with the period pi. So if we prove this result for theta belongs to 0 pi, then it will be holds for all pi, because this is periodic with the pi. So it is enough. So this is an if and only if statement. You can prove this statement also by yes. Now we will prove this result. uh, what we have in hand is that the set R2KW is orthonormal. Then we will prove this identity uh, will be true for theta belongs to 0 pi. Now take R2KW is orthonormal, then we can write inner product W and R2KW equal to, because when K is 0, what will this element in this set? It will be R0W. R0W is W itself. So since this set is orthonormal, we will take W with inner product with R2KW. If K is equal to 0, both these elements will be equal, and the orthonormal property implies its values is 1. And if K not equal to 0, we can say that this is equal to 0. So this statement implies this equation. So now we will take on reverse order. If this is true, then you compute R2KW comma R2JW, which is equal to W comma R2 into J minus K W. This equation we have proved in the note we have proved that this also you can take this lemma 4.41. One minute. Lemma 4.41, fifth statement also you can take this one. Okay, this R2KW comma this R2JW is equal to W, inner product between W and R2 into J minus K W. What is this quantity? This quantity we have written here. If the index here will be equal to 0, then the value will be 1. That is, from here we can write it will be 0 if index is 0. Index is 0 means this J minus K will be 0. J minus K will be 0 means J is equal to K. Here also, sorry, 1 if J is equal to K, and 0 otherwise. So but this means the orthonormality of the set R2KW. So these statements are if and only if statement. So we start with this one and we proved this statement, orthonormal statement is if and only if this statement. Now we prove this statement. This statement is if and only if with this statement. Now from lemma 4.416 we have this inner product is equal to W star W tilde of 2K. So right hand side also follows, then we will get this. Assume again conversely, taking back to the conversely we can prove that if this is true, then this W star W tilde of 2K can be written as this inner product. So then this inner product will be this. So these two are if and only if statement. So we have proved now this is orthonormal if and only if this statement is true. So now, 1 minute. Yes. So we have proved until now this set is orthonormal if and only if this is true. Then for y belongs to L of Z, what is y plus y star of n? Star is defined likewise this, and 2 into y of n is even and n is odd, and this taking this y is equal to u star u tilde. What will happen? This u star u tilde, sorry, w star w tilde you take. This is w star w tilde 4.50. 1 minute. You take w star w tilde. What will you get? There is no u here, so take w star w tilde. What will you get? W star w tilde plus w star w tilde star is will be equal to 2 into delta. Delta we have defined. What is delta of this 0? Yes, delta of 0 will be yes. Delta of 0 will be 1, and other terms will be 0, that earlier we have defined. So what is this w star w tilde plus w star w tilde star? This one is equal to, from here equation, y plus y star of n is equal to, we can write is equal to 2 times w star w tilde of n if n is even and 0 n odd. Okay. Yes. Now what we know that w star w tilde value we already know. So now w star w tilde of 2k is equal to k is equal to 0, we will get the 1. K, if k not equal to 0, we will get 0. So this can be written as is equal to 2 into 1 if n is even, and this, oh sorry, 1 minute, oh sorry, n is even alla, n equal to 0, n equal to 0 we will get 2, and this 0 if n not equal to 0. What will be this value? 2 can be taken outside, so this will coincide with 2 delta definition of 2 delta. What is 2 delta definition? 2 delta definition is 2 delta of n is equal to 1 if 2 uh, delta of n is what is delta of n? Delta of n is equal to 1 if n is equal to 0, and 0 other n not equal to 0. So we will get this expression w star w tilde and plus w star w tilde star is equal to 2 delta. This is analogous to the result that we have proved in the finite case. So taking cap on both sides, this both sides will take cap. So cap is additive. So this comes here and it comes here. That is we have proved here. That is cap comes here and cap comes here is equal to 2, because delta cap of n is equal to 1 for all n. It is I think this is in lemma 4.41, seventh statement. You please refer. And now we know that w star w tilde cap of theta will be equal to w cap of theta w tilde cap of theta, that is lemma 4.412 result, and one also you refer 4.351. Then this w cap of theta and w tilde cap of theta will be w cap of theta conjugate. So we will get this modulus value, and this also you can compute. This is equal to from 4.413 third statement we will get this one. So now we have, if this is true, implies we can write this is true, then this is true, then using these two facts, 1 minute, these two facts applying here, and here we will get here modulus of w cap of theta whole square plus modulus of w cap of theta plus pi whole square will be equal to this 2. So for all theta belongs to R, we have proved this result. So from here we have started. So what is now the condition? We have taken this orthonormal condition, then we have proved here, and here also we have proved. From here we have proved the result. 1 minute, this result, that is we want this result because our first implication is to prove this set is orthonormal, implies this uh, identity is true for all theta belongs to 0. We have proved for all theta belongs to R. If all theta belongs to R, if this is true and this is periodic with pi, then we can say that this is true for theta belongs to 0 pi also. Now we will move on to the converse side. Assume this identity is true, and we will prove that this is orthonormal. So now by starting, uh, this is true. Assume this is true for all theta belongs to uh, 0 pi. If this is true for 0 pi, then it will be true for all theta belongs to R, because this expression is periodic with pi. That is the reason. So we can say that from 0 pi we can say that this is true for all theta belongs to R. What is this quantity and this quantity? This quantity is equal to this one, and this quantity is equal to this one. So we can write this. So from both these facts we can write this sorry, not this equation, this equation we can write by Fourier inversion. This cap will be gone, and we will get these quantity, this quantity. From this quantity we can write this quantity equal to this one, and right hand side will be 2 delta. Right hand side is 2 delta, left hand side is this one. From this, connecting these two, we can write w star w tilde of 2k is equal to 1 if k is equal to 0 and k not equal to 0, it will be equal to 0. What is this one? This one is equal to this one, and from this one we can prove it is orthonormal. So the converse side is also true. So now we have this second result to prove this inner product between different elements of translates of z and w, not different elements, translates of z and w, if e is equal to 0, if and only if this identity is true for theta belongs to 0 pi. This analogous statement also we have seen in the finite case. So now we will prove this one. As this proof is here. Yes, in the same way you can prove this uh, one, because 1 minute. Okay, we can prove this statement in a similar way of as in part 1. You take here, take this inner product as 0. You first initially take this inner product is equal to 0. This inner product is 0 means here we will get, then go to this statement. Here we will get inner product z comma r 2k w will be equal to 0 for all k. For all k, here it is 2k. 2k will be true. Why? Because if this can be written as inner product z comma r 2 into j minus k w equal to 0 for all j k. From here we can write this equation. From this one we can write this inner product can be written like this as z star w tilde of 2k will be 0 for all k. Now, we have this. This is also true for y. If this y is z star w tilde, what will we get? We will get z star w tilde plus z star w tilde. The whole star will be equal to 0. So from here taking inversion, discrete Fourier transform, not discrete Fourier transform. Discrete is in discrete case. Now it is infinite set, so it is a Fourier transform. For taking Fourier transform to this equation, we will get z star w tilde cap of theta plus z star w tilde star cap of theta will be equal to 2, sorry, equal to 0 for all theta. What is this left hand side quantity? This z star w tilde cap of theta is equal to z cap of theta w tilde of theta cap. What is this one? Z cap of theta into w cap of theta conjugate. That will be equal to uh, this one. Sorry, this is theta and 1 minute. Now, right hand side is equal to 0, and both these quantities will be equal to 1 minute. Yes, we now move to S. This at this stage we can write this as z cap of theta into w cap of theta conjugate, and this z star of w tilde, the whole star of theta cap can be written as this format z uh, this z cap of theta plus pi into w cap of theta plus pi whole conjugate. So this equation becomes, now in this format. this format: z cap of theta w cap of theta conjugate plus z cap of theta plus pi w cap of theta plus pi conjugate will be 0 for all theta belongs to 0 pi, because this identity also um, periodic with period pi. You take that pi, because here is theta plus pi, here is theta plus pi 2 pi, this becomes theta. So this will become swapping, and we will get the result for it is true for all. If it is, this result is true for all theta, then we can prove that this result is true for theta belongs to 0 pi also, and conversely vice versa. So in the similar manner, and as in the part 1, you can prove the inverse statement also, and this statement is also true. So what we have proved? We have proved that if this set is orthonormal, then W cap of this is will be 2, and if their inner product will be 0, then this identity holds for all theta. So we will now move on to the definitions for downsampling and upsampling operator in infinite dimensional case. If z is equal to z of n and belongs to z, we will define the sequences d of z and u of z on z, where d of z of n is z of 2 times of n, and u of z of n is equal to z of n by 2 if n is even, and 0 if n is odd. Similar case as in the discrete case, from D, and D is from L to of Z to L to of Z, and U is from L to of Z, L to of Z. The m-fold composition of D, that is D raised to m, or similarly U raised to m, D raised to m of Z of n, can be written as Z of 2 raised to m n. D raised to m is also from L2 of Z to L2 of Z. Similarly, U raised to m is also from L2 of Z to L2 of Z, because infinite times we are taking. Now this um of z of n is equal to z of n by 2 raised to m. M is of the form 2 raised to m j. For j belongs to z, it is not divisible by 2 raised to z. This downsampling operator, upsampling operator, all these facts you know. And next definition: if u and b belongs to L1 of z, two elements, let b be is equal to translates of even translates of b, and even translates of u union is equal to b. If b is a complete orthonormal set in L2 of Z, we call this B as a first stage wavelet system for L2 of Z. So this if we true for L1 of Z, it will be true for L2 of Z also. So now we will prove also another definition: UV belongs to L2 of Z. Then the system matrix, similar as in the case of finite case, A of theta will be 1 by root 2 U cap of theta, V cap of theta, U cap of theta plus pi, V cap of theta plus. From now you will know how why we have proved the first result lemma and other things also. The same theorem analogous to that one in the earlier case, UV belongs to L1 of Z. Then B is equal to R2KU. V union R2KU is complete orthonormal set, that is first stage wavelet basis. This here it is the definition for first stage wavelet system, not basis, first stage wavelet system. System, the word system is used here, first stage wavelet system, if and only if the system matrix that we have defined here is unitary for all theta belongs to 0 pi. For this 1 minute.